Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing what is a Zener diode. A Zener diode is a special type of diode which is designed to reliably allow current to flow backwards when a certain set reverse voltage known as Zener voltage is reached. A Zener diode is a silicon semiconductor device that permits current to flow in either a forward or reverse direction, and the diode consists of a special heavily doped p-n junction designed to conduct in the reverse direction when a certain specified voltage is reached. The symbolic representation of Zener diode is shown in this figure, and the Zener diode has a well-defined reverse breakdown voltage at which it starts conducting current and operate continuously in the reverse bias mode without getting damaged. Additionally, the voltage drop across the diode remains constant over a wide range of voltage, a feature that makes the Zener diode suitable to use as a voltage regulator. The Zener diodes are manufactured with great variety of Zener voltages, and some are even variable. Some Zener diodes have a sharp, highly doped p-n junction with a low Zener voltage, in which case the reverse conduction occurs due to the electron quantum tunneling in the short space between p and n region. This is known as Zener effect. Diode with a higher Zener voltage have a more gradual junction, and their mode of operation also involves avalanche breakdown. Both breakdown types are present in Zener diode, with Zener effect predominating at lower voltages and avalanche breakdown at higher voltages. The Zener diodes are widely used in electronic equipments of all kinds and are one of the basic building blocks of electronic circuits. They are used to generate a low power stabilized supply rail from a higher voltage and to provide reference voltages for circuits, especially stabilized power supplies. They are also used to protect circuits from overvoltage, especially electrostatic discharges. So when it comes to the working principle of Zener diode, the Zener diode operates just like a normal diode when in a forward bias mode, and it has a turn-on voltage between 0.3 to 0.7 volt. However, when connected in a reverse biased mode, which is usually in most of the application, a small leakage current may flow. As the reverse voltage increases to the predetermined breakdown voltage, a current starts flowing through the diode. The current increases to a maximum, which is determined by the series resistor, after which it stabilizes and remains constant over a wide range of applied voltage. A Zener diode exhibits almost the same property, except the device is specially designed so as to have a reduced breakdown voltage. By contrast with a conventional device, a reverse biased Zener diode exhibits a controlled breakdown and allow the current to keep the voltage across the Zener diode close to the Zener breakdown voltage. For example, a diode with a Zener breakdown voltage of 3.2 volt exhibit a voltage drop of very nearly 3.2 volt across a wide range of reverse current. The Zener diode is therefore ideal for the applications such as generation of a reference voltage or as a voltage stabilizer for a low current application. So when it comes to the Zener breakdown is either due to the Zener breakdown effect that occur below 5.5 volt or impact ionization that occur above 5.5 volt. Both mechanisms result in the same behavior and do not require different circuitry. However, each mechanism has a different temperature coefficient. The Zener effect has a negative temperature coefficient while the impact effect experiences a positive coefficient. The two temperature effects are almost equal at 5.5 volt and cancel out each other to make the Zener diode rated at around 5.5 volt the most stable over a wide range of temperature condition. So the different uses of Zener diode are: the Zener diodes are widely used as a voltage reference and as a shunt regulator to regulate the voltage across small circuits. When connected in parallel with a variable voltage source, that is, it is reverse biased, a Zener diode conducts when the voltage reaches the diode's reverse breakdown voltage. From that point on, the low impedance of the diode keeps the voltage across the diode at that value. So the different variable applications are: first one is waveform clipper. Two Zener diodes facing each other in series clip both halves of a input signal. The waveform clippers can be used not only to reshape a signal but also to prevent voltage spike from affecting circuits that are connected to the power supply. Another application is a voltage shifter. A Zener diode can be applied to a circuit with a resistor to act as a voltage shifter. This circuit lowers the output voltage by a quantity that is equal to the Zener diode's breakdown voltage. Another application is a Zener diode voltage regulator. A Zener diode can be applied in a voltage regulator circuit to regulate the voltage applied to a load, such as a linear regulator. So my dear students, in this lecture we had introduced the concept of a Zener diode. So as we mentioned, Zener diode is a special type of diode which works in a Zener breakdown voltage when it is connected in a reverse biased condition. So in a reverse bias condition, this Zener diode acts as a regulator. That means it controls or it regulates the maximum range of voltage which flows through this Zener diode. So dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is: write notes on Zener diode. So dear students, in the upcoming lecture we will discuss the Zener diode as a voltage regulator. So dear students, see you soon. Until then, goodbye, thank you and all the best.